thank everybody for joining us for this presentation. So before we dig in, the first thing that I want to mention is that Autodesk Insight is already included as part of your AEC collection. It's built into Revit, so there's no additional cost to use Insight. Just to give you a little background on energy analysis with Revit in general, essentially in the past, energy models would be a simplification of the Revit model, and this can be basically a time-consuming and costly process to get the model where it needs to be for energy analysis. This is okay if you know what you're doing and have the resources. But now you can actually create an energy model and analysis from any level of model detail from Revit using Insight. Basically, anyone who can create an architectural model in Revit can use Insight for energy analysis. And we're actually talking just minutes to create the energy model and send it to the cloud for simulations, as we will see. So we're going to look at the basics first. What is Insight? Why is Insight important in design? How does it work? As some of you may not yet be familiar, the first question is, what is Insight? It is an online tool from Autodesk that calculates building model energy use and performance, and it's accessed through the Analyze tab in Revit. So you can see up here, it's probably a little bit small for everybody, but basically under the Analyze tab, this is where we would find over here on the far right our information to be able to use Insight. Insight uses cloud-based software to run the simulations based on design. Uses DOE 2.2, Energy Plus, ASHRAE 140 are the main simulation engine platforms that are used, and the simulation engines are validated and updated frequently to meet the standards of those tests. Insight provides a visualization of key performance metrics, and it provides a range of outcomes, which is also referred to as dynamic analysis. As you can start to see in the image on the bottom right, which we'll get into a little bit here, of course, there are sliders that allow you to make changes that will allow you to see those changes and how they could impact the design if implemented in your Revit model. Insight doesn't run just one simulation like traditional energy analysis. It actually runs many simulations at a time. That's actually the most significant feature of Insight, in that it allows the user to input adjustments as opposed to traditional static analysis, which requires all inputs be selected before running the simulation, and then only one scenario at a time can be viewed and can be run. Insight is different from most energy modeling, as it works with your Revit model or your Format model, if anybody's using Format out there, at any phase of the design process. Typical energy modeling is done at the end of the design process, when changes are a lot more difficult to integrate, as we all know. But Insight actually allows us to work with our existing Revit models at any phase of the design. And as we'll explore, it can be used to help generate reports for the Architecture 2030 Challenge, and we'll get more into that at the end of this presentation. So, what is energy analysis? And now, for the sake of argument, or for the sake of this discussion, analysis and optimization are basically interchangeable terms, and I'll probably use both throughout the presentation. Energy analysis is a basic comparison of model scenarios, comparing things like building orientation, building envelope construction, glazing percentages, material thermal properties, and basic mechanical and HVAC systems. Now, the next question might be, why use energy analysis? Well, first of all, because it's easy. Secondly, it helps, and secondly, and most importantly, it helps understand the impact of your design decisions on building performance and energy use. It can be used to demonstrate that the design meets specific energy guidelines, and again, that would be based mainly on ASHRAE 90.1, Architecture 2030, but also state energy codes as well. So let's walk through a little bit on how to actually run the energy analysis with Revit. Obviously, we'll walk through this process a little bit more detail in the slides to come, but just to give you a general overview of the tools in Revit, we'll quickly walk through the Revit user interface here. One significant note is that the model actually does not have to be watertight. I know with a lot of traditional energy analysis, that's one of the big questions that comes up. So Insight actually accounts for this. Where other energy modeling software requires more stringent enclosures, And again, this can partially be the reason for a majority of energy analyses taking place toward the end of the design process when the Revit models would be near completion. Insight actually allows for inconsistencies and gaps in the model, and we can actually set the tolerance for the simulations in some of the settings that we'll review later. The only required setting, and I'll reiterate, the only required setting to run Insight with Revit is location. Insight will run a range of outcomes for you, so it's not necessary to be versed in all of the advanced settings. That being said, you certainly can work with more advanced settings, and I would recommend getting familiar with them. We'll review them a little bit, but there's actually going to be a second part to this webinar in this series where we'll get into some more of the nitty-gritty of the settings and the like. But I just want to emphasize that you don't need to be well-versed in order to effectively run and utilize Insight. So, as promised, let's walk through the Revit user interface here just a little bit. So let me exit out of here and just walk through the settings that we can use. So again, I mentioned that the Insight is basically built into your out-of-the-box Revit installation. So over here under the Analyze tab, over here you're going to find the different tools that we have available to us for using Insight. So again, location, the only setting that's required to run basic analysis in Insight is right here. So you can actually click on this here, and then we kind of get what anybody that's ever set the location in Revit will recognize this dialog box. So we can set the location of our project, and again, that's the only thing that we need to set. Create energy model. Well, here it actually says delete because I actually have one created just for the sake of this presentation. But normally what this is going to say is generate energy model, and as soon as you generate the energy model, what will happen is Revit will actually simplify the model a bit so that you can, so it's something more appropriate for energy analysis, and it will create a new 3D view for you. So this is a typical 3D view that we're all accustomed to when working in Revit. You'll see here over on the left in my project browser that I now have an analytical spaces model. So basically once we've created the energy model at that point, we now see that we have a new 3D view. And this is what we would basically use to send to the cloud into Insight 360. There are a couple other options or buttons, settings that we have here. So generate, basically this sends to the cloud for the simulation analysis right from the model. So what happens is if I click on this generate tab, and while I have this open, let me show you. So in my email, what I'll get is basically an email that says, hi Nick, your model has been received. It'll take some time to process that actual model in the cloud, but once it's ready for you to view, and we'll click on this tab in a little bit here, but once it's ready to view, and it will depend on the complexity of the model essentially. But once, it can take anywhere from 10 minutes to 45 minutes to an hour. So once the model has been sent to the cloud, you will get this second email that says View Insight, and you can go directly to your model in the cloud. And again, we'll take a look at that here shortly. Optimize, basically this actually takes you right to Insight 360 rather than through the email. So Optimize and Insight more or less do about the same thing. One is just working more so in the background, whereas Optimize takes you directly to Insight on the web interface. And then energy settings, we'll get into these a little bit more. Some of the more advanced settings here, and even more so in the second webinar. But basically, this is where you can start to click on this, and a dialog pops up, and this is where you can start to refine some of the settings that we want to use with our analysis. Again, just to reiterate, the only thing that is required is this location setting, but I at least want to walk through some of these energy settings with you. Let me get back to presentation here, current slide. Okay. So, because we can use the existing Revit model at various stages of the design process, there are a couple different approaches depending on the stage and style of the model. The questions that you really should be asking yourself as you start energy analysis with Revit are kind of, what are my analysis goals? I.e., is it preliminary studies, feasibility studies, facade studies, design development review, etc., those types of things. What is the design stage? And what modeling style is appropriate for these goals, i.e., what level of detail is existing in our model already, or what needs to be created in order to meet the goals of what we're trying to accomplish with this energy analysis. So depending on what stage you're at and what your goals are, there's going to be different levels of detail within your model, anything from massing to something that's basically in design development or even CDs. So for the sake of this discussion, there are basically three types of modeling styles. The first is massing, as I just mentioned. That's the most simplest and one of the most effective ways to use Revit to optimize energy for building design. You can create one or more masses to represent the overall building shell, and also the surrounding buildings, if applicable, that would potentially be shading the building if those are something that exists. You would also want to create mass floors for any of the masses that represent the actual building, so it can start to kind of chop your building up into just one giant, as opposed to one giant mass. It'll start to break it up by floor for you within that massing model. The next style is mixed design, and that's really that method is used as a combination of massing and detail elements. So as you start to define the model and so if you're starting in schematics or just kind of doing some basic massing studies, and then you start to turn those massings into detail level models as you go through schematics and into design development, you may still have some massing elements present while you actually use some mixed with detailed information. So again, as I mentioned, Insight and Revit paired together will allow you to use the software at any phase of the design process. Again, one of the most important things of the ability to use Insight. On that note, by performing that analysis through the design process, you can basically continually review your model as it evolves. And while on discussion of starting to add detail to the model, I want to touch base on one term. It's not on the slide here, but it's the term room bounding. When model elements are set to room bounding, which you can actually access in Revit. So let me bring up my Revit model again here. So let me just click on any particular element here. So when I click on, say, I'm just going to click on this roof here, you'll see here over in my properties palette, there's actually a little box here that says room bounding. So what this means is Revit will use anything that is listed as room bounding we'll use that in the creation of the energy model. So you can start to see how introducing detail beyond the massing starts to inform and affect the resulting energy model. So the more information that's built into the model, the more information that's going to be used in the simulations in the cloud with Insight. Let me bring that back up. And by default, any elements when they're created in Revit will be checked as room bounding. So if, for example, there was something you didn't want to be room bounding, more often than not what you would be doing is unchecking that room bounding setting as opposed to actually checking it. Some of the major elements that can be used for room bounding are ceilings, columns, curtain panels, curtain systems, curtain wall mullions, doors, floors, masses, roofs, soffits, shaft openings, site pads, walls, windows. Most everything that you're going to put into, that you're going to use for your actual model itself, is going to be used in the, in the calculation as long as it's set to room bounding. The last modeling style that I wanted to cover was basically what's considered a detailed model. So that's you can essentially start energy optimization, energy analysis with a detail model late in the design process, if that's how that's how you choose to work. However, as the model evolves, we may start to have a blend of the mass elements and detail elements to some degree. But once we get into the more detailed elements, this is where it starts to require us to discuss more detailed concept settings, requirements as the model becomes increasingly complex. So, as I mentioned, we'll touch on a couple of these throughout this presentation, but more so in the second part of the webinar series is looking at some of those more advanced settings if that's the type of analysis that you wish to accomplish. So, all that being said, I want to discuss some of the components of the energy model, just to give everybody an overview of how Insight actually works and how that energy model that we saw created. I'll go back to it one more time here in Revit, how we actually use this simplified energy model once we're in how that's actually created and how Revit creates that model. So, spaces, surfaces, and zones are the three main components of an energy model. This illustration here on the bottom right actually shows spaces labeled as number 1 with the dot, surfaces as number 2 with the red line, and zones as number 3 with the kind of the gray box. So spaces are volumes or masses of air that experience heat loss or gain. And as a note, an accurate heating and cooling loads analysis, which will be something that will be discussed more so in the second webinar, that can only be accomplished if spaces are placed in all areas to account for the entire volume of your building model. You would actually place spaces just like you currently place rooms in a Revit model. And that's basically through the Analyze tab. There's an option to, let me just pull this one back up one more time. So under the Analyze tab, under in the spaces and zones, we can actually start. This is grayed out because I'm in a 3D view right now. But this, if I were in a plan view, I could place spaces just like I would place rooms in a normal Revit model. These heat changes in the spaces are due to internal processes like occupancy, lighting, equipment, and HVAC, as well as heat exchange with other spaces and with the exterior environment. Sorry about that. For linked models, if anybody has any existing conditions or other linked models, you're doing a campus type project. If there's any type of linked information or you're working with consultants, you would want to set the link as room bounding as the room bounding parameter in the type properties of that linked model as well, in order to use those elements as space bounding from the linked file. So again, like any detail element that you would add to a model, if you had a linked model in your Revit model, you want to make sure that that's labeled as room bounding as well, so that the energy model that's generated accounts for that information as well. Surfaces are the paths of heat transfer to or from each space, including surfaces between interior spaces and the external environment. We'll get in a little bit more depth in spaces and surfaces here shortly. And finally, zones are groups of spaces used to establish some commonality between those spaces. Zones consist of one or more spaces that are controlled by equipment, similar to how your MEP consultant designs zones for common environments. Spaces in an unoccupied area, such as a plenum, can be added to zones. Spaces that are different on our different levels can actually be added to the same zone as well, similar to what you see here. And you can create zone schedules and use the zone schedule to modify zones in Revit like we would create any other type of schedule within Revit. Now, let's walk through some of the main energy settings that you may work with here in Revit. So I brought up a little image here. We just saw this here in Revit a couple minutes ago. This is the main dialog that pops up when you click on the Energy Settings tool, and we'll walk through the different tools that are the basic settings for Revit that are in here. So this image shows the default energy settings for all new Revit files. So this is, if you were to open up the energy settings in your Revit model now, this is likely what you should see. The building, for a complete energy model, the Revit project must meet two requirements. First, building elements must be reasonably enclosed. Now again, the model does not need to be watertight. There can be small gaps and overlaps, and as they are certainly a natural part of real architectural models that we work with. So they are expected and allowed. So that's a nice deviation from standard energy modeling by using Revit and Insight. And the second requirement is that the settings for your analytical space resolution and your analytical surface resolution are adjusted to meet the needs of the model detail. And again, more on this here shortly. So let's walk through some of these standard settings here just so you can become familiar with them a little bit. Revit actually offers 3 different modes for creating the energy model from the architectural model. So this over here, this setting, is showing right now use conceptual masses. For all cases, however, I recommend that you should use the default mode, use conceptual masses and building elements. So I wouldn't use this. I would use the one that's labeled use conceptual masses and building elements. The reason for this is this mode does not require that the architectural model include both conceptual masses and building elements. It basically allows, what it boils down to is it allows for any type of level of detail in the energy analysis through the model. So by using that setting, you can pretty much run your model at any stage of the design process. It also supports the mixture of the 2 element types that we discussed earlier. So if you have massing and detail elements, that obviously makes it useful when using energy optimization throughout the design process, as I mentioned. The other modes really relate to kind of legacy behavior within Revit. So they are provided only to support older models. So again, I would just reiterate that just use the use conceptual masses and building elements setting, and you should be set for any type of energy analysis that you want to do. The ground plane setting here specifies the level which the energy model surface is assumed to be in contact with the ground for heat transfer. So I want to make a note on that. So basically, if you were to have a building where the ground floor is partially underground, for example, built into a slope, for the sake of argument, you would use the level with the most exposure as the ground plane, as the differences in the resulting energy analysis are typically fairly minor. So really, it's whatever comes in contact with the ground for heat transfer. The project phase, as I assume most would imagine, just means that all the building elements and/or conceptual masses assigned to that specific phase or an earlier building phase are included in the energy analysis that you create. So any elements or masses assigned to a later building phase are omitted from that energy analysis, assuming you have this dependent on the project phase that you set here. So for example, in this one, new construction, anything that we have on our new construction phase, as well as anything that may have been existing, will be part of the energy analysis model that's created. The analytical space resolution, this setting right here, this is both the analytical space resolution and the analytical surface resolution are parameters that provide important information used by the algorithm that generates the energy model. So the default values for these parameters provide an optimum balance between energy model accuracy and processing time for most Revit models. However, because Revit model size, complexity, quality, all of that can really vary, you may need to modify these parameters to provide greater accuracy or to reduce processing time. You kind of have to find a happy medium or a balance between accuracy and speed, depending on what your timeline is in your workflow. When you increase the value of the analytical space resolution and analytical surface resolution settings, the processing time required to create the energy model is actually slightly reduced. Basically, you're giving it a wider berth than what the default settings are. So that would, of course, reduce the analysis time. When reducing these values does not necessarily result in a more accurate energy model, however. So, for example, while a lower analytical space resolution value can result in smaller gaps between the Revit elements that are allowed, it can also lead to the omission of some analytical spaces due to the gaps between the architectural elements that will be ignored at a higher setting. So it's just a matter of kind of fine-tuning and playing around with these settings a little bit to see what works best with the model again, goes back to those initial questions that you want to be asking yourself when you start the model. So what level of detail, how, what kind of minutia do I want to get into with these settings, and more to the point with the results that come from the energy model itself. The analytical space resolution defines the minimum gap between Revit elements that will be ignored in the identification of the energy model spaces. So this goes back to the notion that the model doesn't have to be watertight. analytical space resolution is the primary parameter that influences the energy model's accuracy and processing time. So this setting right here is what is really going to dictate how long it takes once you've sent it to the cloud. So between the first email that you get saying that my apologies, that it's been accepted versus the second email that you get saying that it has been processed and is ready for your review. That amount of time is going to be dictated by a number of these settings, but mostly by this analytical space resolution. It is the so for that parameter, just to give you an idea of changing the numbers, the default value, as we can see here, for the analytical space resolution is 1'6". The minimum value would actually be 6 inches, and the maximum value is 10 feet. So you can see there's a pretty wide range of the settings that you can use for this. As far as the analytical surface resolution goes, that drives the ability of the algorithm to find individual analytical surfaces. It really should be less than the smallest dimension of any surface to be included in the energy model. So for the analytical surface resolution parameter, the default value that we have here is 1 foot. Our minimum value we can work with is 3 inches, and the maximum value again is 10 feet there as well. So our next setting here would be the core of a building has heating and cooling loads that differ from the perimeter because it's not directly exposed to external weather conditions or daylight through windows. So the perimeter zone depth, this setting right here, specifies the distance between measured inward from the exterior walls to define that actual perimeter zone. Please note that this doesn't really ever need to be changed unless you feel you can unless you have adequate natural ventilation in the perimeter zone based on orientation, windows, etc. So this is that 15-foot zone depth is kind of a standard across hundreds of thousands of models. So you can safely assume, unless you're really getting into the minutia and you know that you have that adequate natural ventilation toward the core of the building, you can just leave that at 15 feet. For the perimeter zone division, you would just select this option to divide the perimeter of the building, excluding the core, into discrete thermal zones. So by dividing the perimeter into zones, that allows for more accurate energy consumption estimates. The setting should always be enabled when the perimeter zone depth is greater than 0, which it typically will be. An example of this is if in the late summer afternoon, a west facade may encounter solar heat gain while the east facade does not. So the perimeter zoning allows the energy analysis of these perimeters to be handled separately. One thing that I do want to point out with where you can see under other options under advanced, for the energy settings, there's one other category titled building type, which will come into play when discussing Architecture 2030. So let me just show you that as well here. So if I go into my energy settings, here's that dialog that we were just looking at on the PowerPoint slides. If I click on here, you can see here there's a list of a number of different settings. But when we get into discussing Architecture 2030 reporting a little bit, this building type is also one of the settings that you want to have set as well. So for the Architecture 2030, we'll want to have the building type set as well as the location. So once we move into the kind of the realm of doing reporting for that, we have a second setting. I know I said location is the only setting you have to run for basic analysis. When we get into Architecture 2030 reporting, we want to make sure that we're also setting that building type as well. One other thing I want to mention in regards to the energy model is deleting the energy model. So sorry for jumping back and forth here. So when I had mentioned up here, normally it says generate energy model. Because I actually have an energy model generated, once I have an energy model generated, this button will now turn into delete energy model. And if I were ever to kind of make some changes to the model, so I've gone into Insight 360, we've gone through design options, whatever the case may be, we've basically made changes to our actual Revit model. We want to delete the energy model and regenerate because it's not going. This energy model, this view is specific to a time along the timeline of the design process. So we want to be able to have to regenerate that energy analysis to account for any changes that would go into our model from there on out. So let's see here. So interacting with Insight 360 via the web interface. So at this point, we have created our energy model in Revit. We've adjusted the settings if necessary, and we've sent the model to the cloud for simulation. So now let's walk through the user interface for Insight 360 in the Internet browser. So you can see here this is what it looks like, but I will actually open up my browser here. So here is Insight 360 in the browser. It's basically just insight.autodesk.com, but it will also be where you would get sent to once you click on this button here, this link to view Insight once your model has been sent to the cloud and fully simulated. So just to reiterate, the beauty of Insight is that it allows the user to compare the effects of different design scenarios without actually affecting the Revit model itself. So as you can see, we'll get our standard Autodesk 360 viewer if you've ever done anything in any type of the 360 platforms. The analytical model can basically be navigated, zoomed, sectioned, rotated, any of the normal things that we would typically expect within navigating a 3D model. In the upper left-hand corner here, we have our energy cost mean. We'll get into this a little bit more in a minute. In the bottom left, we actually have our geographical location, which, as you recall, we set in Revit under the Analyze tab. And then as we move down here a little bit, the first block in the second row, this one right here, gives us what's called our benchmark comparison. This shows the Architecture 2030 and ASHRAE 90.1 benchmarks in relation to the highest and lowest possible cost range, otherwise known as the best and worst scenarios based on our energy usage. Both the energy cost mean and the benchmark comparison update simultaneously. So this will update simultaneously to any changes that we make in the dashboard below as we walk through them. And ultimately, your goal is to get to green. The middle block shows us our model history. This tracks all the changes that you've made to this particular energy analysis, but does not apply to the Revit model itself. So any changes that we make in these sliders does not actually apply to our Revit model. This just allows us to see what making these changes, what effect they will have on our energy cost mean and our benchmark comparison down here, and then we would translate those changes to our Revit model. So here you can see that there's been as I played around with it prior to this, there's a couple changes that I made. So each time I make a change, it logs up here under the model history for this particular analysis. The rest of the blocks that we see here as I scroll through, and actually let me just flip a couple of these over. This is actually what you'll see when you first open Insight. So it looks more like this. So it gives you a kind of a title for each window pane and gives you a little bit of an explanation as to what each one are. As you want to go in and start to explore with the sliders, the range of outcomes, you can flip that panel over. So pretty much it gives you a full landscape of all the things that can really drive energy modeling. So clicking anywhere on any one of these, so if I click on this pane here, it basically opens a second dialog box that shows an active slider as well as the energy cost mean for our overall model. So here you can see the different settings that are in here. So this little triangle right here, this is what's called the BIM setting. So this is basically pinpointing what has been modeled in our actual Revit model. It's been sent to the cloud, and then this gives us these sliders give us the range of what else we can look at. So you can start to see as I start to move my sliders how that adjustment changes my energy cost mean up here. And then what I can do is I can slide this back over to, so I'm at $2.65 per square foot. If I slide this over a little further, and then you can see as you move it around, you can see so here we're looking at our window shades in the west. So you can see what what we're actually changing it to within these panes. But more importantly, you can see how sliding this setting around, it's very minimal here, but it starts to change our energy cost mean here. So again, instead of simulating one value, these sliders show several values, and by using that slider, we can see what those changes would do. Basically, an immediate cause and effect so you can see where an increase or a decrease in the energy cost range and benchmark comparison based on these changes that we make. Of course, it's not always easy to make some of these changes, like orientation, for example. I'm sure if anybody's ever tried to rotate your Revit model after, in DD, you know how troublesome that could potentially be at times. So you just really want to use this and use this to review some of the settings, be mindful of what adjustments you can make and what impact they would have on the energy uses. So for example, we would see what changing the percent of glazing or increasing the percentage to see what that would do to the energy cost mean. So what I do is I just click out of this box, and now you'll see here if I scroll up, you'll see here that here I have adjustments made to my model. The critical thing to understand really is that not only are we testing what is modeled, but that there's a range of scenarios that drive the cost of the energy. So we can actually save scenarios. So up here in this little flyout, I don't have anything saved, but you can actually save scenarios here, so you can make some adjustments and label it whatever. I've changed glazing on a north facade. So say I actually changed, I changed it from 20% glazing on north facade to 50%. I could actually go to my flyout, create a new scenario, and save that, and then I can toggle between the scenarios. One thing to note, let me scroll down to find something. So the one thing I wanted to note was that the steeper the incline of the values, the more opportunity for potential savings. So let's actually go into one of these here. So we'll go into the lighting efficiency. So you can see here, here's my actual BIM setting. So if I take it back there, you can see how my energy cost mean changes to $3.94. But if I slide down to the lowest, which I'm sure would probably be very difficult to get to, but you can see here how using this slider starts to show us. If I go up to the highest level, you can see here now I'm in the red as opposed to down here being in the orange. So you can see how the steeper the incline, the more opportunity there is for energy cost savings. And as I mentioned, just using this little X here to close the docs brings you back into this page. So I mentioned that I wanted to talk about energy cost mean just a little bit more. So what you can see is we can actually set the energy cost mean to either basically cost or EUI. It's often easier to use for users to see the energy cost mean represented as dollars per square foot as opposed to EUI. I'd recommend using the cost, even though 2030 references EUI, just to get you started. It's just what more of us are more accustomed to understanding when using that software. So you can see here, just to give you an idea of the color range. So red equals poor, orange means that we're hitting the ASHRAE 90.1, green means that we're hitting meeting architecture 2030, and then green with a negative number means that we're at net zero. And let's see here. So one other thing with interacting with Insight 360, Insight, it can be used to basically quickly compare design scenarios. So if I were in Insight 360 here, and I go click on this little back to Insight, it's going to take me into the main splash page for Insight for us, and you're going to see all the different models that I actually have loaded into my Insight 360. So there are basically two ways to compare the model design scenarios in 360. One is on an individual model, and we saw that with the model history panel. So you can see what various changes have been made through that model history panel up at the top. And then the second is more along the lines of what we see here. By going to the splash page, you can compare different models against each other. So say you have something in schematics, then you've loaded in design development, and then in CDs, and at the end of construction. You can actually compare these against each other, and here you can see there's a slider available for the model comparison for those as well. All right, so how do we actually utilize these tools in meeting the Architecture 2030 Challenge? For anybody not familiar, the 2030 Challenge is essentially a series of stepped goals to create carbon neutrality by 2030. By essentially reducing fossil fuel consumption. The goal is 80% by 2020 and 90% by 2025. There are two components to Architecture 2030. The 2030 Challenge basically states that all new buildings, developments, and major renovations shall be carbon neutral by 2030. It was issued in 2006, asking the global architecture and building community to adopt a set of targets, which you can find on the Architecture 2030 Challenge website. The 2030 commitment is the structure to support and track progress based on the targets established in that 2030 challenge. The 2030 commitment was created by the AIA to support the goals from the 2030 challenge by helping to transform, quote unquote, the practice of architecture to respond to the climate crisis in a way that is holistic, firm-wide, project-based, and data-driven. As I mentioned before, you actually only need 2 settings in Revit for the 2030 comparison. Again, that would be location, which is what you need for any type of basic insight to be run through Revit, as well as the building type, which I showed you in the advanced settings. We discussed both of these when reviewing those energy settings. So at its simplest form, you only need to have these 2 settings selected in order to generate reports for Architecture 2030. Just a note, lead energy models and reports require a great amount of detail. But the Architecture 2030 Challenge does not is more relative to the 2030 benchmarks as opposed to the lead. So you would have to do a little bit more legwork if generating any information for lead energy models. So how do we actually use Insight to help with the 2030 challenge? There's a direct link from the model to the 2030 design DDX, which stands for Design Data Exchange. It creates a report that can be sent directly to the company's site on DDX, where you can compare to other benchmark projects across the entire country. This allows you to pull the report at more frequent intervals through the design process. So when you are in the Insights project page, you actually click on the little ellipse. So you can see here, this is where I was on the splash page. So if I click on this ellipse to the right of the model, you're looking to create a report, and you'll see multiple export options as shown in this image, one of which would be the report to the AIA DDX. If the company doesn't already have a registered and approved DDX site, you'll need to 1, register, and 2, enter the firm key and the user key in Insight so that you can generate these reports. And then you can notice that you'll have an option to easily edit some of the input prior to hitting send from the dropdowns. And then as soon as you hit send, you're then taken into the AIA DDX report page, where you can start to see all of the information that would be available in that report. So I think we're nearing the end here. We're about to get to Q&A. So I just wanted to have one more slide to just kind of wrap everything up and kind of walk through a quick summary of the workflow that we've discussed here today. So step 1 would be to create a Revit model at any phase of the design. Step 2 is to set the location, and then building type as well if we're taking it into the DDX, as we just looked at, through that energy settings dialog. Again, these are the only required settings to run Insight. Then you would create the energy model, and that creates a new 3D view in our project browser. And again, this step can take a model at any level of detail and simplify it so that it can be used in the energy analysis. We would then review the energy model for any major gaps or issues that could create issues in the simulation due to any particular leaks. And as we discussed, that the model does not need to be watertight, as Insight certainly accounts for a lot of these small gaps, but we do have settings that we can manipulate if we want to kind of refine those settings. We would then send it to 360 for simulation and review through the Generate or the Optimize tabs in Revit. And then we would review the results in 360 and finally export those results to Architecture 2030 DDX if that's where we're taking the model.